I'm excited for your talk. I know that you've been doing some of the most advanced stuff out of anybody that I know when it comes to just thinking through agents and how really like the computer use agents and the web browsing agents work. I'll hand it over to you, man, and then we'll be back and we can have this roundtable in a bit afterwards.
Cool. Yeah, that sounds good, man.
All right.
All right. So we were talking about R1 computer use today. A little about me. I'm the CTO of Kentauros AI. We focus heavily on GUI automation, specifically a little bit beyond browser automation, where we're just doing multimodal models that operate directly off of a keyboard and a mouse. And we've been working on this for about a year. So it's been a really fun project to work on. And I think we're coming along the way to some things that are pretty exciting. So, R1 should need no introduction. Obviously, I think everyone's heard of it in the last couple of weeks. It's a tremendous success using sort of hard deterministic verifiers and gRPO policy loss. And we can induce reasoning relatively cheap, which is super exciting. And obviously computer use as well, which I'm sure people have been hearing about. The most recent one was OpenAI's Operator. But yeah, there's a long history that sort of led up to this. Obviously, we had Clip, which is sort of the backbone of a lot of vision language models today. Then we had Flamingo, which was really the first open question answering vision language model. Then we had Molmo this last year, which a lot of people actually don't know about, but AI2 is doing really incredible work. The cool thing about Molmo is the full training recipes available. So they open source their data sets as well, which I wish more people would do. But they were really the first people to release a grounding coordinates data set, which is really exciting, of about 1 million examples. And this is just super critical because vision language models, pretty much all of them are not trained on this data at all. And if you're telling it to like, hey, I need to click on something on a screen, that data was just horribly out of distribution for a really long time, and there was no large data set. We at Kentauros actually collected a pretty large data set of about 80,000, and it worked fairly well. But then Molmo was released a couple months later, and they have 1 million data points, which is amazing. So Molmo was really a big release to the community that I think is kind of under-recognized in a lot of ways. And then, yeah, about a month later, Claude, came out with computer use. There's sort of the first frontier model to do that. And then, last month we had Operator as well. These are all really exciting developments. What I'd say is, none of them are reliable yet. So this is definitely a problem we haven't cracked yet. It's getting better, but, we only see roughly 60 to maybe 80% reliability in general, for any sort of medium grade task. So yeah, we can highlight sort of computer use struggles overall. Clicking, like I just said, historically, vision language models horribly out of distribution for this. Recently, like the Molmo Pixmo data set is probably the best one on the market right now. So this problem's getting better. We're seeing a lot more click models that are quite reliable. Reasoning, this is still out of distribution for almost all VLM models, for like specifically for computer use. I don't know of actually any data sets. I think Kentauros has a very small one we've started and we're growing, but I think that's the only one on the market that I'm aware of currently. And then recovery, what I mean by this is if the agent fails, which they're going to fail frequently, you really need to train it to recover from failed states. This is critical. I think one of the first papers was the PyNot paper that really talked about this, which is a robotics paper. But they really showed that training on recovery is as important as training on like a perfect run. But the irony is in the ecosystem, there's almost no data sets that do this. Every data set is like golden runs, and it's just a series of golden runs. And really what you actually want is about half and half. So you want half the data to just be like a perfect run through the task on the computer, and the other half to actually have a bunch of errors that the model has to learn to correct from. And then reliability overall, they're just not. I just kind of talked on that a little bit. We're seeing, really 80% max on any just medium grade task. On harder tasks like multi-app tasks, stuff like that, it's much, much worse. We're seeing about 10%. and OS World's currently the top benchmark kind of in the space. It's really, really poorly put together. So we're actually very close this month to releasing a new benchmark. We're calling OS Universe. So that should be out soon. Um, so yeah, I got wondering, obviously as R1 was released, and we've been sort of playing with the reasoning stuff for a while, but could we combine the R1 style reasoning with computer use, and could we solve some of these problems leveraging the work that they did? Uh, the big challenge of this is that R1 relies very heavily on hard verification for the reward models. And what that means is, like, if I do a math problem, it has one answer, and I can verify that immediately, and I can deterministically know if it was right or wrong. And why this is so important in the current state of the world is that if you use a non deterministic method and use a model for the reward, the actor model will generally find a way to hack the reward model. And it's just kind of this funny thing we've been dealing with in reinforcement learning for a very long time. And so the reason why hard verification works so well is it really forces the model to create a true representation in its latent space of the reasoning. And so this is kind of the primary challenge of trying to apply that idea to GUI data. And this is because we really just don't have hard verification at scale for GUI data. Like, you can go through and do some hard verification tasks for certain types of things. It's fairly limited, and it's really cumbersome to collect that data. So there's really just not a lot of this data that's out there. And so we got wondering, could we do reasoning reward models, right? And what I mean by this is, the top one, you have an actor, and the actor is doing sort of a React style loop. It's going to observe, it's going to think, and then it's going to act. And then you have the reward model, and the reward model would do something very similar. So it would observe, it would think, and then it would reward. Um, and so the question becomes, how do we train a reasoner that is potentially capable of doing this? So we've developed sort of a platform, which you can see down here, that allows you to review agentic actions as they take place. And our hope here is that we can scale enough human labeled data to train a reliable reward model, or at least the start of that. And the exciting part is, if that is possible, then the agent would be able to learn autonomously, which is very exciting. So we're rapidly heading towards this goal. One challenge we've immediately faced is it's a lot slower. So when you add the reasoning data to, say, the actor, they're already quite a bit, they're already quite slow. So you add more reasoning data, they get even slower. So the thing we've been playing with now that seems to be working is you train once with reasoning, and then you train just another example, same model and everything. You train it without reasoning. And the idea here is that it will create a shared latent representation. It's almost as though the reasoning, when you train it on that one, is is guidance for the attention in a way. And then once the attention's sort of been learned in that format, then you can usually get away without the reasoning. Now, this, the reasoning continues to work a bit better, but you'll see that, without the reasoning, it gets significantly better. So this is a pretty promising approach. I haven't seen a lot of people doing this yet, so I think it's fairly novel. And then where are we, in the process of doing this? We are currently collecting sort of this base training set of reasoning data. We've started training some base models for this with the limits that we have. We have annotators kind of working around the clock on this. We're gathering quite a large data set. And then, soon we're going to be starting up with the RL style training. And if you're interested in this work, we just open sourced a repo called R1 Computer Use. And we are building this all on the open. The data sets are giving me the open. And something that interests you, we'd love to chat. So, that's all I got for today.
So awesome, dude. So to echo that, I think there's something super cool that you're kind of crowdsourcing the whole getting quality data, because that's where you're seeing the biggest bottleneck or the most difficult part, right?
Yeah. That's definitely the hardest part with the computer stuff is we don't. There's really not many data sets at all that exist in the world. So the way we're thinking about this is, it's easier to verify that an action was correct than it is to take the action, right? It's significantly easier, and models are already quite a bit better at this. If you think of like LLM as a judge, sort of, is really rapidly becoming LLM as a reward model, right? So the idea is because it's easier for the model to do that. It'll hopefully take less training data to train a reasoning model that can be a reward model. And then that model trains the actor. So it's a way to sort of hopscotch up, and then you can sort of have it just run off on its own once the verifier, approximates human signal enough, which is similar to what we do with RLHF. Actually, it's just sort of now being applied to reasoning.
But the MoMA set wasn't enough to get like you can do this R1 on it, and it didn't work enough.
Yeah, so the Momo set is the main thing I think they added is Pixmo, which is a clicking. Well, it's not really clicking; it's a coordinate grounding data set. So, given an image, sort of like the old convolutional, detection things, where you get an image and draw a bunch of bounding boxes.
Mhm.
LLMs have historically been very bad at this. So I'd say their biggest contribution was Pixmo, which is about a million or 2 million data points that is just like really high quality grounding annotations. And so that way you can actually like move the mouse and then click on the appropriate thing. And so I'd say that has taken us a long ways. On our benchmarks for clicking, we've gotten, trained on Pixmo, we get about 87% accurate on most things with the clicks, which is pretty good. We've got some other sort of training techniques. We've worked into that, and we've gotten it close to 90% now. So it's getting better. We still need, I would say, Pixmo is still a little light in GUI data. A lot of it is just sort of like robotic style data in the real world, and we could use more sort of GUI interaction grounding data. Would probably take that further. So.